In a previous chapter, we talked about electrons, and I mentioned that electrons are very important because they're the part of the atom that we focus on when we're dealing with bonding. In this chapter, we're going to get into what exactly happens to those electrons when bonds are formed. Before we get to that, we need to do a little bit of simple explanations on how we determine charges and what are valence electrons. So let's get started with that. Valence electrons are the electrons that are in the outer shell of the atom. So they're those ones that are in the very last ring where electrons are held. We can determine the number of valence electrons based on the location of the element on the periodic table. All of the elements in the alkali metals have one valence electron. All of the alkaline earth metals have two valence electrons. We're going to skip this entire section with the transition metals, and that's because they have multiple oxidation numbers, which means that they form multiple ionic charges. So they have different numbers of valence electrons depending on which one we're dealing with. If we move over here to the column that starts with boron, those have 3 valence electrons. The next column has 4. The column beginning with nitrogen has 5. With oxygen has 6, with fluorine has 7. This last column with the noble gases, if we're dealing with helium, helium in particular has 2 valence electrons, but all of the rest of the elements from neon all the way down to radon has 8 valence electrons. So again, we can just look at where an element is located on the periodic table and we can determine the number of valence electrons. Calcium has 2 because it's in column number 2. Aluminum has 3 because it's in column 3. Chlorine has 7 because it's in column 7. So all we do is look for the column that the element is in, keeping in mind that helium has 2, while the rest of the noble gases are going to have 8. The octet rule means just like it sounds. It means that we need to have 8 electrons in our outer energy shell. So we have to have 8 electrons in the valence shell. And the reason we want this is because it makes our atom more stable. So we do it for stability. Keeping in mind the number of valence electrons that we have in each column on the periodic table, we can tell immediately how many electrons need to be added or taken away to end up with a full outer shell. So for example, if we're dealing with oxygen, oxygen is going to want to gain 2 electrons in order to have a full outer shell. And that's where we start to see how the octet rule works with bonding. Every element wants to have that full outer shell with 8 electrons. So when we gain or lose electrons, it gives us the full outer shell. And that's our goal, to make us stable. So let's continue on with this. Because of their desire to follow the octet rule, atoms are going to gain or lose electrons to become more stable. Recall that we said in column 1 that all of these elements, from hydrogen all the way down to francium, they all have 1 valence electron. So let's use lithium as our example. In a neutral atom of lithium, we have 3 protons in the nucleus, 4 neutrons in the nucleus, and then we have 2 energy levels. In the first energy level, we have 2 electrons, and in the third energy level, we have 1 electron. So that's where we get 1 electron in our valence shell. What happens is that that electron in the outer shell is going to go away. Okay, so it's going to be removed. And when it does that, it leaves lithium with a +1 charge. And we talked about that in a previous chapter. That happens to all of the elements in column 1A. Lithium, sodium, potassium, rubidium, cesium, and francium will all lose their 1 valence electron and end up with a +1 charge. All of the elements in column 2A, beryllium, magnesium, calcium, strontium, barium, and radium, will all lose 2 valence electrons and have a +2 charge. Boron, aluminum, and so forth will lose 3 valence electrons for a +3 charge. Now we're going to scoot over here to the noble gases, so column 8A. okay, they already have a full valence shell, so they don't want to gain electrons and they don't want to lose electrons. So they have no charge whatsoever. The column with fluorine will add 1 electron to have a -1 charge. The column with oxygen will add 2 electrons to have a -2 charge. The column with nitrogen will gain 3 electrons to have a -3 charge. The column with carbon is a little different because it's as easy to gain 4 electrons as it is to lose 4 electrons. So in this column, they can either gain or lose electrons to have either a plus or a -4 charge. You have to look at what atoms are being combined with carbon to figure out which charge it's going to be. So again, just looking at the location of an element on the periodic table, we can automatically determine its charge. Calcium will have a +2 charge because it's in column 2A. Nitrogen will have a -3 charge, and iodine will have a -1 charge. It is important that you're able to look at the periodic table and determine the charge of the electron based solely on its location. If you have questions about this, please make sure you ask Mrs. Benke in class.